Hey thinkers, welcome back to Think Sharp Alley, where every turn leads to a smart solution.
This class 11 question is breaking the internet. Some websites say the answer is a plus b plus c, others say minus half of a plus b plus c. But here's the shocking part. Most of them don't even check if their method actually works. We are given 3 quadratic equations and told that each pair among the equation has a common root, and we have to find the sum and the product of 3 common roots. Students generally do this. Let alpha be the common root between the first 2 equations. So alpha will satisfy equation 1 and 2. So we have substituted alpha in place of x and eliminating alpha square. Then we are taking a minus b common. So from here we get either a minus b equal to 0 or alpha minus c equal to 0. So alpha is equal to c if a is not equal to b. Similarly, if we take beta to be the common root between equation 2 and equation 3, we get beta equals to a if b is not equal to c, and gamma equals to b if we take gamma to be the common root of equation 1 and equation 3. So alpha plus beta plus gamma, that is the sum of the 3 common roots, is equal to a plus b plus c. Sounds perfect, but let's test it. We are taking a counterexample. Let us take a equals to 1, b equal to 2 and c equal to 3. So the equations become this. And if we go by this method, it says the first common root of the first 2 equations, that is, let's say alpha, will become 3, right? Now let's check if 3 is actually a root of the first 2 equations. So first equation, let us put 3 in place of x. We are getting 3 square 9 plus 3 plus 6, so which is equal to 18. That means not equal to 0. Let us check with the second equation. Again we are getting 9 plus 6 plus 3, which is also 18, not equal to 0. So 3 is not even a root, forget being a common root. Now let us understand what went wrong. We proved that if a common root exists between equation 1 and 2, then it must be c. But we assumed c is definitely a root. These are not the same thing. Let me explain. When we got alpha is equal to c, the statement is if alpha is a common root of equation 1 and 2, then alpha must be equal to c. Symbolically, we can say alpha is a common root implies alpha is equal to c. But what you used it as, which is the mistake, we then treated it like alpha is equal to c implies c is the common root. That is the reverse implication and it is not logically valid. Now why this matters, let us take an analogy. If I say if a number is divisible by 4, then it is even. But if I reverse this statement and say if a number is even, then it is divisible by 4, that is not logically valid. Same pattern here. So if alpha is a common root, then alpha is equal to c. So just because alpha is c doesn't mean that it is a common root. So the real check that you must do, if you conclude that alpha is equal to c, you must verify that c actually satisfies both equations 1 and 2. So x equal to c implies c square plus ac plus bc, c taken common, so c into a plus b plus c equal to 0. So c is a root only if this product is equal to 0 or c equal to 0 or a plus b plus c equal to 0. So this is an extra condition. Our first method gives a necessary condition for a common root. Any common root must be c. But for that root to actually exist, parameters must satisfy this condition. So if this condition is not true, then there is no common root for that pair at all. So our starting assumption doesn't hold for those a, b and c. So in the first method, we did this for each pair of equations and concluded that alpha is equal to C, beta is equal to A, and gamma is equal to B. But for all three to hold together, we are forced into the condition A plus B plus C is equal to 0. That's a new restriction not given in the problem. So our assignment works only in special case, not in general. So let's correct our approach. And we assume that the roots of the first equation be alpha and beta, second equation be beta and gamma, and third equation be gamma and alpha. Now let us apply sum of the roots and product of the roots formula. Now adding these equations, we get this, and so alpha plus beta plus gamma is equal to minus half into A plus B plus C. And multiplying this product of the roots, we get, and now taking square root on both sides, we cannot fix the sign plus or minus here because we don't know the signs of alpha, beta and gamma individually, and no extra condition is given. So this is our final answer. The first method works pairwise but fails when all conditions come together, because in maths, a condition that works in parts may fail as a whole. And I hope this cleared your doubts and gave you a better way to think about such problems. If you still have questions, drop them below. I'll be happy to help, because sometimes the smallest clarification makes the biggest difference. So make sure you save it and share it with someone who might be stuck on the same doubt. See you in the next one.